In this video we're looking at the idea of forces and braking, and it's part of Unit 2 for Physics or for GCSE Additional Science for AQA. Now in the scenario here we have a car that's going at a steady speed, and we've looked at this before in a previous video, but basically we have the forward force made by the engine, that's the driving force, and we have what we call a resistive force, and that's made up of mainly air resistance but also a bit of friction of the tyres on the road. Some people will argue that air resistance is actually friction of the air against the car. That's fine, but I'm just dividing it up into these two for this video. Now the biggest one out of these two is usually the air resistance, and what we have as a result of these two forces being equal is the car is going at steady speed. Now what we can do is we can increase the resistive force in order to slow the car down, and for the purpose of what we're talking about today, we're going to just talk about how that's done by using the brakes. Now when the driver applies the brakes, what we have is the movement energy or the kinetic energy of the car that gets converted into heat energy. Now the reason for that is that we have friction of the brake shoes against the wheels, so that causes friction, and that friction is then converted into heat energy, and that heat energy is then given off to the surroundings. So when a car brakes, all that kinetic energy is converted into heat energy in the brakes, and that heat energy is transferred to the surroundings. Now let's see how we can apply this to some data about the time required for a car to stop. Now what we have here is a car moving along at steady speed. Let's just for argument's sake say it's going at 20 miles per hour, and then all of a sudden out of nowhere we get a rabbit which jumps out in front of the car. So there's a rabbit slowly faded into the path of the car there, and what happens then is the driver will then want to stop in order to not hurt the bunny rabbit. Now there's two things that have to happen before the car can stop, and the first one is that the driver has to react, and while he's reacting what happens is the car moves a certain distance. So this orange bar here represents the amount of distance the car has moved while the driver is reacting. So in other words, taking in the sight, sending a message to the brain sending a message to the foot in order to apply the brakes, and by the time all that has been done, the car has moved a certain distance, and we call that the thinking distance, the distance moved by the car while the driver is reacting. Now once the driver has finished reacting, he's going to, or she is going to, apply the brakes. So what we have then is a amount of distance that the car takes to stop. The car doesn't stop instantly, it takes a few meters of distance for it to stop. Now in this scenario we can see that the thinking distance and the braking distance have stopped the car in time so that the rabbit is not hurt. Let's just have a look at a key down here. So we've got three things here. We've got the thinking distance in orange, we've got the braking distance in red, and together they make the stopping distance of the car. Okay, so this 20 miles an hour represents a certain amount of kinetic energy that the car has due to its speed. Now let's imagine that we have the same scenario, but this time the car is traveling at 30 miles per hour. So the car has more kinetic energy, therefore it's going to take more distance for the car to stop in order to dissipate that movement energy that it has. So what we have is, assuming that the reaction time is the same of the driver, it takes a bigger distance for the driver to react, so therefore we have a bigger thinking distance, and also the braking distance is longer as well. But luckily in this scenario we can see that the rabbit has just about been saved. It doesn't quite hit the rabbit there. Okay, but there's two points here. We've got the stopping distance made up by the thinking distance and the braking distance, and we've also got the faster the car travels, the longer that stopping distance is. But what can happen is the thinking distance and the braking distance of a car can be affected by different factors, and you need to know what they are. So let's take the same scenario again. Car's driving along, we've got thinking distance and braking distance, but imagine that for some reason the driver is either tired or has been drinking alcohol or has perhaps taken drugs. What could possibly happen there is that the reaction time is a little bit longer. Something else that could increase that reaction time also is a distraction. So imagine the driver is on a mobile phone or fiddling with the stereo or something like that. That will also increase that thinking distance, and therefore increase the time before the brakes are applied. So the amount of time the car takes to stop is the same once the brakes are applied, but you can see, because of that extra thinking distance or the extra reaction time, the car has traveled further before it stops. And actually I think the poor rabbit here has been hit in this scenario. The other thing that can happen is that, let's assume the driver is not tired or hasn't been drinking or hasn't had drugs or not distracted. We can then assume that the thinking distance stays the same, but the braking distance could increase, and the reason for that could be something to do with the car or something to do with the road. And in terms of the road, we're talking about things related to probably weather, so it could be wet, it could be icy, or something like that, and that would then increase the braking distance. The other thing that could increase the braking distance is if there is something wrong with the car. So for example, if the tires are worn down or the brakes are faulty, that could increase the time it takes for the car to stop because it's not functioning properly. Now, of course, the other thing is we could have someone who was tired or had been drinking alcohol and a car that's not in top shape, or bad weather conditions. You can imagine that would increase the stopping distance much further. So what you need to be able to do is to be able to interpret data that you might be given based on thinking distances, braking distance and stopping distances. And something that's quite typical for you to have to be able to read is something like this. So we've got a table of data, if you like, here, and we can see for the various speeds the amount of time it takes to think, or the thinking distance and the braking distance, assuming conditions are equal for each case. Now at 30 miles an hour, which is about 13 meters per second, we've got a 10 meter thinking distance and a 15 meter braking distance, and altogether it takes 25 meters for the car to stop. And you can read the rest of the table for yourself, but as you can see, the faster the car is moving, or in other words, the higher the kinetic energy, the more distance it will take for the car to stop given the same braking. Okay, so that's about it for this video. Do remember that all the videos that are made are listed in order for all the Unit 2s and all the Unit 1s on the website www.my-gcsescience.com.